Very good evening to one and all. And I, Dr. Manu Sahani, welcome you to the fifth day of our faculty development program on smart manufacturing and digital transformation in Industry 4.0. So, over the past few days, we have had the privilege of gaining valuable insights, engaging in thought provoking discussions, and enhancing our understanding of various key topics. Today, we continue this journey of learning and collaboration with another exciting lineup of sessions and expert speakers. So, let us make the most of today's opportunities to exchange knowledge and ideas. So, without further ado, let's begin. So, before we proceed, I would like to invite Mr. Dharmik Chauhan from Pandit Deen Dayal Energy University, Gandhinagar, who will introduce our esteemed speaker, Dr. Ashish Shukla, sir from NEMTech. So, over to you, Dharmik.
Good evening, sir. Good evening, everyone. I, Dharmik Chauhan, Junior Research Fellow, Department of Mathematics, Pandit Deen Dayal Energy University, Gandhinagar, Gujarat. Today's our expert is Dr. Ashish Shukla. It's my pleasure to introduce our esteemed speaker, Dr. Ashish Shukla, Senior Assistant Professor at NAMTech, New
Thank you so
Age
much, Dharmik.
Education and Skill Foundation. Thank you, sir. Gandhinagar. Dr. Shukla brings with him over 6 years of post PhD experience and impressive academic and professional background. He has held key roles include assistant professor and director of CIIE and patent content at Atlas Skilltech, University Mumbai. Postdoctoral researcher on prestigious Indo-Asian project at IIT Indore, visiting assistant professor at NSUT Delhi, project engineer for defense project at IIT Kanpur. He also served as honorary director of Smart Eye Hub Technology Provider Limited as spin-off from the mechatronics and instrumentals lab at IIT Indore. Dr. Shukla holds an impressive academic portfolio, PhD in molecular energy and material science from IIT Indore, MTech in production and industrial engineering from Delhi Technological University, BTech in mechanical engineering for Uttar Pradesh Technical University, Lucknow. His professional membership include esteemed organizations such as the International Solar Energy Society, SPIE, Indian Laser Association, and the Indian Institute of Metals. He is also a reviewer of multiple prestigious journals, including materials, letters, surface and coatings technology, and solar energy materials and solar cells. Dr. Sukla's primary research areas include WAM, laser hybrid micro and macro manufacturing, laser welding, laser cladding, laser stock bending, and surface cleaning, laser assistant open air and underwater micro nanostructure generation, flexible photoelectric application, and microfluidic application on smart materials. With such a diverse and impactful portfolio, we are excited to hear Professor Dr. Shukla today. Thank you, sir. Welcome you, sir. Over to you, sir.
Dr. Shukla, you are on mute.
Yeah. Thank you, Dharmik. Thank you so much for your very elaborate and detailed introduction. And please
Thank you,
allow
sir.
me to share my slides and proceed for this session. Thank you. Should I? Yes, thank you. So hopefully my screen is visible.
Yeah.
Yes,
Am
sir,
I?
it is visible.
Okay, thank you. So let's begin for the today's talk. Yes. Is it in screen? I mean, full screen mode? Yes, is
No,
it?
no. Yes, yes.
Yes, it is
Yes,
on
sir.
full screen mode, sir, please.
Sure. Thank you. Thank you so much. And please feel free to stop me at any point of time if you feel that I'm in any questions or anything I have to address. Please let me know. Sure. So I would be talking on the role of robotics in manufacturing and industry 4.0. And before that, of course, I'm from Namtech. So, role of robotics in manufacturing and industry 4.0. So, first of all, how this robotics and the robotics in academia and robotics industry. So, industry is holding as a part of robotics, and academia is primarily a key concern about the robotics. So, both of them, how and what both can do for each other. That's a primary concern since beginning. Whenever the robotics started, either in industry or academia. I mean, someone can say it started in industry, someone can say it started in academia. But of course, I mean, either way, it is very important to do the job simultaneously. So when it comes to the what we can do, both of together for each other, we have to discuss a problem basically. That is a first foremost fundamental. Second thing is like what solution is required either in industry or the academia, or industry can help for the academic people to find a solution, or academic people find help industrial people to find a solution. Then defining a problem statement, sitting together and doing it for the robot in manufacturing and industry 4.0. So this is the basically the entire paradigm what we are going to discuss today. It's very important. So like I mean in left side you would be seeing that thinking time is often undervalued. It is rarely if ever quantified in employment practices. So probably such kind of the definition of the thinking or finding a problem or finding a solution would have led to the identify the cause of robotics. So robot in manufacturing, is it I mean should we define on the robots in manufacturing, robot of robot manufacturing, or basically robot is a part of industry 4.0? How it is, I mean how you are perceiving, that is very important, and what definition suits to you. So let me come to some points. These are the standards. What is the definition of robotics? Because sometimes people used to say each and everything which can act autonomously in the definition of the robotics, but which is not true case basically. So always whenever you are defining or identifying any class of the mobile mechanization or the robots activity, you have to search about the its standards basically, which help you to identify or guide which should be considered as a robot or which should not be considered as a robot. So basically ISO and IEC both maintains the standards and terminology for the databases basically. Now industry 4.0. So if I'm writing to you, dear recipients, in a mail, because I mean in industry 4.0 the communication is also a part of parameter. So if I'm writing dear recipients, or I'm writing dear sir, or I'm writing dear sir, madam. So how many of you are okay with this kind of the writing, or how many of you would you like to hear such kind of the writing basically? Probably numbers may be less, or this may not be very attractive for each one of you. So what is that? This era is called mass creation for the email or the production basically. I mean you can take it this as anything. Let's say if anything starts for the production, it starts with the communication initiation. Then so how many of you like this? Probably very less. What you like is basically mass personalization. Let's say if someone is writing me dear Ashish, I would be more attracted towards that mail rather than any other. I mean, either like dear recipient, dear sir, or dear sir and madam. So basically, how to deal with such situation? So you can see in this image that since industry, I mean 0.0 was also a situation when the handlooms were there and the functions were mechanized. I mean functions were there, but those were the manually operated. But now we are into the mass personalization domain. So that mass personalization domain is very important. It's going to move from the mass production. So I can say it's basically a mass customization, which era is now you are going to face very soon. And right now you are in the industry 4.0, maybe applied at every place or not, but the era is about to. And also I mean may be possible that India is lagging behind by some number of years, so it can go with that also. Now coming to the point, robot across the field. So robot across the field is very important. So this is the operational stock of the industrial robots across the world. If I may ask you one question related to this, in which year the most number of the robots were installed? Would you like to would you try to answer, someone of you? Anyone, any student can please, because I mean students are more updated or they are frequently using the multiple chat option or anything, I mean chat GPT and other things also, so they may answer frequently. But yes, the rate of growth of the robots are by the rate of 12%. So which year industrial robot installation was the highest? Can anyone judge out of this? No worries. I mean, you can later on also you can answer during the question answer session. So in 2022, it was the highest year, and 2023 was the second highest year in terms of the number of robots installation across the globe, or the I can say the industrial robot or the second highest in 2022. Now, coming to the point, I mean, which one is basically I mean, annual installation in which fields and how it is diversified. So you can see the automotive is also a leading industrial segment where the largest robot installations are happening. Electrical or electronics, of course, it is, I mean, leading in 2022, but in other year, it may be low or, yeah, in 2023 the electronics is reduced because of the low demand. So this is the field, diversified field of the industries where the robots are installed basically. Which country is this one? Can you guess, someone of you? Anyone? Please feel free to speak. It's a two-way communication, not only I'm only speaking. So no worries. So this country is basically India at the seventh number. So at the seventh number, it's around 8.5% in 2023. And the important part is like first, I mean, though we are at the seventh number in the world market, so which application is the more, I mean, is this one? Can anyone try to identify? Because it is used in welding, it is used in assembly, it is used in clean room, dispensing, processing, and all other specified processes. So yearly, you can see the graph. It was referred the graph of the International Federation of Robotics. It's a no-profit federation, basically. Anyone can be the member of this. So, can anyone please try to guess which application is this one, which I have hidden? Anyone?
Painting.
Painting, of course, good one. I mean, that comes under the processing basically, but this is the material handling process. So almost 60 to 80% of the market varying from the globe. I mean, in geographical way, the differentiation of the material handling keep changing, but it goes up to the 80% and minimum up to the 60%. So what you all learned so far basically, let's have a discussion that what was the I mean about 8 or 9 slides, what help you to understand basically scope of application. So simple application is basically a material handling. So that first thing you learn is the scope of application, where you can identify the robots application or the deployment or the functioning or the engaging for the industry 4.0 application. Now the second thing you learned about the scope of market. India at the seventh number. So every day the installation of the robot across the globe keeps on changing or it's increasing simultaneously. So the scope of robotic installation in India, it's also getting increased. So now coming to the very important point, how you are going to do with this and what you are going to do with this. Basically, the scope of market is going to help you to improve the robotic application. It is going to improve the robotic operation. It is going to improve the maintenance. It is going to improve the entire ecosystem of the manufacturing basically. What's your action now? Basically, can please someone try to explain what would be your action after looking these two, I mean, learning or this learning so far? Anyone? What would be your action? Would like anyone, please? Okay, so in terms of the action, learn how to design a robot. It should be your first and foremost action. Second one should be learn how to utilize robot, and third one is learn how to visualize a robot. So these three things are a very different in nature, but simultaneously it is required for each and individual robotic application. So can someone suggest that how to design a robot? Anyone would like to throw some light, or would you like to enlighten to some of us? Please feel free. I mean, though I'm delivering, but everyone can participate as a discussion or a guidance part as well. So When it comes to the how to design a robot, how to utilize a robot, how to visualize a robot, so for first action you need a robo analyzer, you need a, MATLAB Simulink, you need Python is, I think, there is no cost associated with the Python. You can feel free to design your robot with the help of Python. Robo Analyzer, of course, it is a free software. You can identify the action of robots. You can find out different parameters of the robots. So those things also you can go ahead with the Robo Analyzer. It's a free of cost software for the academic purpose. MATLAB Simulink, it's a paid one, but you can access it for the 30 days. Second, learn how to utilize a robot is basically find a problem. It's the biggest challenge, find a problem basically. Now, how to visualize the robot? So there are the softwares called Technometrics. There are the software called Mechatronics Concept Design. There is a software called Emulate 3D. So above two software, Technometrics and Mechatronics Concept Design, is basically a software from Siemens. It's a generic software. It does not require that only this make of the robot, if you are having this is going to work. No. So basically these two softwares are helping for the generic robot. Emulate 3D is also going to help you with the generic robot. It's a, I think Rockwell or PTC. I think it's a PTC software. Then it is a RoboDK software. Then RoboGuide. RoboGuide is from the Fanuc, and then Robot Studio from the ABB. So these are the things. I mean, once you are planning to make an application, or once you are planning to cater a market, these things you need to prepare either from the initial level or to the last level. So this entire thing is going to help out, because I mean every people may not be expert in every domain, but how you are going to help yourself identifying which is your key area, like designing a robot, maybe your key area, utilizing a robot, maybe your key area, or visualizing a robot is a key area. So basically, why I'm taking much time on the visualization of the robot, because I mean, every project there is a cost applied with this. So the application of the cost can be reduced with the help of visualization software of the robot. So let's say if any entire scenario you are having to, or the problem you are having to build upon using the robot or designing a robot, you have to make sure that it is working properly, it is getting installed properly, its process is simulated properly, its the plant is simulated properly. So all those things, if you are able to visualize, if you are able to utilize the robot in the visualization, if you are utilize your designed robot in the visualization, you would be able to convince people for your application basically. So now coming to the point, let's discuss a problem. What problem I had, 1.5 year before, was how to find the composition of the steel basically. Now you would be saying, what's the relation of the composition with the robot? Composition of steel with the robot. Problem two, how to take sampling and the temperature of the steel basically. Now, it again, you may think that what is the relation of the robot with the sampling and the temperature. Another third problem was like how to handle a material basically. Of course, the material handling, you are knowing that this is the growing field where it is very important that how to handle a material robot may be utilized. So in above two problem, you may not be finding scope of the robot. In third problem, you would be able to relate the scope of the robot. So how to do that basically? Let's discuss problem linked to the Indian market basically. So how to find out the composition of the steel, how to take a sampling and temperature, and how to handle a material. Here, I would like to pause and show you a small video, maybe of 10 minutes. If you can please allow me. Am I allowed?
Yes, sir. Yes, sir.
Thank you. So, please, try to see this video as, with your appropriate attention. Yeah. Am I audible? So, would somebody want to speak about this, whatever they have seen? Hope I'm audible.
Yes, sir.
Yeah. So, does anyone wish to speak about this, whatever the video uh, we have gone through? Would like to someone? What was that? Okay, so let me speak about that video and then we'll come to the what was the problem for me initially. So, when this particular system was there, so this entire system, I would say, was divided into many parts. So, first of all, if you are seeing this, if you are seeing this, so this is a basically automatic operation. So my question to everyone is like whether every automation is a robotic or the robotic is a part of automation. So basically I understood is the robotic is a part of automation, so every automation may not come under the category of robotic. So here the one robot which you are seeing near to my this scroller is like to receive the materials, and the materials, can you believe how, since how much distance, I mean how much distance the material is transported to get into this cell? It is almost from 1 kilometer, or maybe sometime it is from 2 kilometer. It is a vacuum transport. So once the material is received, then we need to get into this. This is the material transfer unit. This robot is basically helpful for identifying the recipe, correct recipe, because to get the details or the composition of the steels, you need to do the certain processes. So once the certain processes is done, at last its chemical composition is identified, and finally it is transported for the this particular zone where you can see microsur is there. So there the samples are basically stored. So still I can think that there may be possibility that it is not understood to everyone over here. But what simply I would like to do is like so basically I mean the entire problem is defined into three. One is like how to find the composition. Of course, you need to take a sample out of the furnace. Secondly, you have to take the temperature out of the furnace. Then you have to ship that material to the system where it can be identified. So for me, you can see the video over here. It's happening. What human being is doing over here? Just please see this video very carefully, and you can understand the toughness of the people while doing their job just for their food, how difficult it is, and how robot can help this. Can you assume in this video the temperature is inside the furnace is around 16 to 1800 degrees Celsius. The second one is like again they are doing the sampling. So in that sampling, how things are done basically. So again, the human being is exposed over there. They are having the temperature jackets with them, but the problem is that these temperature jackets are not going to help them to restrain that. So what we have done over here, we have tried to identify a robot sampling and temperature measurement basically. So you can see the third video how it is done. So once this is basically done, the our what is our purpose is to objective is to eliminate the human intervention, reduce the cycle time, increase the worker safety, consistency, and accuracy as well. So the same over here, you can look into this system. So the now the part is like how you can do the robotic design. This was the challenge for us, that near to the furnace, how we are going to implant our robotic solution, what were the phases we have gone through with that, and what was the basically I can say the critical challenges we have faced while doing one entire activity. I'll quickly go through in the details of this particular example. This was developed by the visualization software basically, and I'll go through its detailed version of this. So this is the cycle basically, which we opted for the entire uh, problem solution. Is it visible or still it is loading?
No, sir. Still
Loading, sir.
loading.
Okay, just allow. Yeah, I think it is visible.
Yes, sir.
So the development journey for the robotic sampling and temperature was basically the CAD modeling of the entire structure. I'll show you how tough the structure was. Lace and cartridge. Of course, I mean for good designer or the for beginner, the toughness or I can say the level of uh, level may vary basically. Lace and cartridge design. Then you go for the robot payload analysis, selection of the robot placement, then robot kinetic analysis, then proof of concept of the deployment, how the entire situation was taken. So this was the entire layout. It was, I can say, uh, I mean, almost 5 acre of the area. This was there where we did this entirely. So then first phase for us was like, I mean, how to make its 3D model first of all of the entire scenario. This 3D model was built, and after building, then we have to identify. Basically, we have to place the furnace over here. After placing the furnace, the second task was identify the area or the scope where this entire deployment can be done. As I said, three way, like design the robot, deploy the robot, or visualize the robot. So here, I mean, the robot was standard, applications were designed, or I can say the solutions were designed, and the deployment. Here we are doing the visualization part basically. So these were the two areas which you find out that the robots can be deployed. We identified the area as closely or as much we can utilize maximum. So lens and cartridge design came into the picture. You can see it over here that I mean the lens and cartridge, the symmetricity of the lens you can observe it's a highly unsymmetric job, and you have to club it into the robotics. So robot takes care of the every unsymmetricity of the job into the payload capacity. If the job is symmetric, the payload capacity will reduce or maybe in very conformal level. So just a question I would like to throw over here. Let's say it's a weight is 21 kg. Can you assume that what would be the payload capacity? You may try to figure out while I'll be progressing my talk. So this is the cartridge. This is the, I mean, who is the supplier? What is the material basically? And now this is the process which you saw into the video. Now we have to automate this. This was the person, how they are lancing this, till what depth it is going. So all those things are given in the detail to us. But now how to make it robotic operation. So this side, it's a robotic, I mean, I can say the 2D version of the image is provided over here. Now, so this is the lens analysis, because you need to do the moment of inertia. You need to do find I mean center of mass, center of gravity, everything you have to find out when you are going for the payload capacity. So payload analysis. So this is the one just reference. So similarly we did for the KUKA. I mean KUKA, of course it is shown over here. We did for the FANUC, we did for the ABB, we did for the universal load. So the entire verification, whatever the payload capacity we are going to choose, should be verified up to the multiple level. Of course, I mean the make which you are going to choose may vary and change the little bit, but yes, you will able to find out the range. Still, you may be thinking about what would the payload capacity of the lens which you are going to, I mean, introduce in the robot. So we did, I mean, the chosen robot is passing the criteria, but I mean, what is the analysis? So we tested one more model. This is also passing the criteria. We tested one more model. This is the failing the criteria. And this is failing at A6, means joint number 6, it is failing. So, I mean, even that is a more typical if it is failing at the joint number 6. So the chances of failure will keep on increasing. Now, the gantry, they have to identify how and what they can do with the gantry. They can place the robot on this. And this is your entire simulation. And this was done using the Technometric software. The similar now I'll come to the part. You saw the video. That video is also the entire process. Maybe modeling, maybe designing, or maybe through certain processes, or maybe through video making as well, or the representation. But once you are going to make similar visualization, it should function in the operated way. You have to identify certain software which can help you to make this robot work, because this robot is a basically a black box. It requires brains, basically it requires controller, it requires the another level of the brain. If you are going to operate more than one robot, it requires another level of controller, which is called generally programmable logic controller. So those logic controllers handling the multiple number of the controllers and then multiple robots, along with that multiple accessories has to be managed. So those things are done over here. Basically you can see how this process is taken care over here. So in left side, you can see the robot is placed, robotic gantry is placed, safety gate is placed, temperature lamp is placed, push button is placed. So these are not just a 3D visual representation that I made a block of the cylinder, I placed the light and probably it is glowing and I try to make the animation that it will glow and it should not glow. No, that's not the case. Basically in right side, you can see the simulation panel. Entire each and individual activity you have to simulate it. Basically the another difficulty is like you have to simulate and integrate it with the your hardware, the robot, as well as your PLC, programmable logic control, or the controller of the robot, whatever you wish, because sometimes people directly operate robot with the PLCs or sometimes directly through the controller. So this is the one of the difficulty range which you can come across if you are designing a solution. So this is the another part where the typical is like, as how I mean, when you are going to make some electrical things or the electronic things to work, you are going to make a hardware connection or the other way of the connection. So the hardware connection, as you are doing similarly, this has to be programmed. It seems like a hardware input as well as the output. So input of the one signal of the robot to the output of the other function is very important. So it's like a hardwiring in a simulated version. So there difficulty comes more than simulating a scenario. Like just making a robot run, you can of course go by the by clicking or the joking the robot, you can do the that work. But when it comes to the linking input and output, probably that's where difficulty lies. In hardware you can see this wire is not connected, but in software you can't be able to see that which wire is not connected and probably why my robot is not functioning well. So these are the difficulties. And when it goes to the next level, so the another part of the problem, you can see the right side, the programming or the other differences has increased. Here what we have to check, whether we have to check its interference analysis, whether my any of the component is not hitting with I can say the near and around surrounding. Here this is the predefined part. This is the predefined part. This where my scroller is there. There you have to find out the gap for the sampling. So this is the process basically. And now when it comes to the another level, so the simulation, like the HMI panel. So HMI panel also you have to simulate it. So I'm not saying that the sequence is random, but yes, you have to prioritize the sequence. You have to prioritize the objective of your uh, I can say the integration. So whatever, why these things are used for the plant commissioning or the plant simulation, because these are very appropriate in their dimensions, so it will not miss. Once your geometry is uploaded from 3D model or the geometry is uploaded and the robot is placed and robot is not interfering while making the installation, actual installation of the robot, your robot will not interfere with any of the objective. These steps are followed very carefully. Now, so these are the again, whichever we have seen. So initially what is going to happen, that now the human being intervention will come into the picture. So this side human being, you can see the left side human beings are there. So now what will do, the person initially which you have seen in the video, that who is taking the temperature and who is putting for lens for the sampling, that person was exposed to the 1600 degrees Celsius, though the environmental temperature may be 200 or 250 degrees Celsius, but he has to see into that well. Now, how to make his work as humble as possible? So once this entire process is done, so human being is taken 4 or 5 meter behind. So now the human being can place the cartridge in, it will acknowledge and it will do its job. So basically the intervention of human being can be checked over here in the entire process. And when you are going for the next, so there are the 6 or 7 different scenarios were taken care into the consideration while developing this entire project. Still, I mean, line operation, but the side of the entire things are changed. So here the key safety advancement they are taking care. So once if any, I mean, any automatic pressing of the safety buttons are there, then it will automatically stop and it has to resume from the same points. Execution timelines. So now I'll come to the very important point of this, like what are the other challenges basically, and I will try to make you visualize what are the 6 different frames were observed in this. Yes. So total 4 or 5. Yeah, total 5 types of the proofs of concept were made. So this is basically, I can say, the beauty of visualization of your robotic application solution or the robotic solution. So in this, you can see that how 2 furnaces were analyzed in detail and where to place this particular robotic applications were identified, keeping in mind that all other scenarios were taken into the picture, or all the scenarios of the processes were taken into the picture. So those are the things. Now in this, again, the similar things you will observe here. Yeah. So these things we have discussed in detail, the every development journey. These were the steps taken care while developing the process. And now the key safety advancement was developed over here. So robot stops automatically when safety gate is open. We'll see that. Yeah. So the safety gate is open and the robot got stopped automatically. Yes. So now this robot resumed from the same point. What next we were supposed to do that we can see the, I mean, your lamp is glowing, it was acknowledged, button was pushed, safety gate was again open but stop. The next point was it should resume and come back to the home position. That also we have to visualize because this was the demand from the customer side that yes, you have to show us this visualization as well. So similarly, retrieve from the home position, this was the developed to retrieve from the home position. So the emergency was pressed, it came to the home position, and now again it will start from the home position. So this entire visualization was related to that. Now going for the next one. So along with this, what was the another critical phases we have observed and what were the important again instruction? I'll come back to this slide. And in relation to this, basically, yeah, so far we have covered out of this is like how to find the composition of the steel, how to take a sampling and temperature, and how to handle them. So how to take sampling and temperature. So this we have observed. Now we are going to observe how to handle the material. If it is an n number of the material, let's say in a day, you need to handle a 1200 samples. So now I'm giving you the scenario. If I have to handle 1100 samples at 5 different locations to complete my recipe or the recipe of the entire steel plant, how would you be planning your activity? So basically for that activity, I will take you to the another presentation. In that, we'll see how this. So in this slide, you would be seeing the similar setup, which is basically, I mean, in Germany. But now this setup is in India, and we have to make it the indigenized version, how this can be done. So I'll come to this slide where is, so this setup we have designed thoroughly, we have thought process, we have made different versions, we made the trial or the visualization that how my robot would function, what are the advantages and disadvantages of this application, and what is basically layout finalization activity we did. So the virtual simulation you can see in, I'll show you the different type of the virtual simulation. So total 5 or 6 virtual simulations we have done. I'll show you one simulation over here. Is it visible?
Yes, sir.
I think some difficulty lying in playing this in, you can say, the full screen mode. Just try to visualize. So one robot is over there. So total 3 robots we have made working in this. So the first robot, what is doing after the home position, it is going to take the sample. A small red color sample was there. Now it will come and place for the milling operation. After placing it for the milling operation, it will go to the home position. Now the second robot will activate. This sample was taken and it will go for the punching operation, because these are the recipes where the material has to be handled basically. So this material was having the only milling operation, punching was not desired for this. Now this the second robot will go and it will take the sample and it will go for the OES. What is that OES now comes into the question. It's a optical emission spectroscopy, which is going to identify the composition of your steel material or the any material in a metallic domain. So it has given the sample to the OES2, and once this sample was taken, it will place over there because another robot is handling for the 2 OES stations. And now this robot will take the sample and place it for the needle printing, sample marking, and post the needle printing, it will go to the bin where it has to be placed. So this is the our version of making the entire process. And initially the video which we have seen was the German version of the making this entire process. So we have to think thoroughly. We have to value our thinking, how the application can be designed. We need not to be very similar to anyone, but you can uniquely identify the pros and cons and you can design your solutions as well. Now, coming to the proof of concept. Yeah. So I'll show you the hardware, how we did this hardware entire process or proof of concept programming. So I'll show you how this entire process is done. So the out of the scene, we are having two robots to demonstrate this application. But the other features like milling machine and punching machine is a dummy process. For that, we are accepting that this is basically a time elapse. So at some place, we are identifying the sample just for the time elapse. But there also we are having uh, sample identification whether the sample is placed or not. So for similar kind of the things, we made the proof of concept, and once the entire time elapse will complete, we would be able to do its yeah. So post writing the sample number, it is placed over there. I think writing a sample number, we can see. So this process was basically to write a sample number. There are the possibilities to write the sample number and take the sample back. So similarly, we emulated the five or six different scenarios for, taking our entire process. We did this entire process for at least 11 sample initially, then we went for the 36 sample, then we went for the 126 sample. Our target was to do the 1100 entire sampling, but we could not go up to that level because of certain limitations. But yes, our target to make that 1100 sample processing done through this as well as the we have to do the entire 1100 through the simulation as well, because eventually we had the similar setup where only few setups are dummy, like milling and punching on OES. So we were able to demonstrate wherever such setups are not available, we are having the resource of only visualization of this entire proof of concept, which we are able to do that. So there the cost of the other factors will reduce, cost of the setup will reduce, those things we would be able to do that, and there we can test and trial a number of the processes. So further, we did this entire, but before going for this entire things or the selection of the robot, this was the entire criteria and the characteristics. We have to identify at each joint level what is the importance of the rotation, how many rotation we need in entire process. So those things we calculated for, let's say in 24-hour time duration, we need to handle 1200 samples, and out of that 1200 samples, how we would be able to make our robotic operation thoroughly, what is the saving time for of our robot. So we have analyzed over here three different type of the robotic operation. Let's see whether it is, if it is loading properly, I'll show it to you. So let's say the total number of rotation in joint 1 degree is like 10 lakh 80,000 rotation in the joint one is desired. We did for the robot one, we considered the Fanuc ArcMet robot. Then we considered another Fanuc and three models. So similarly, here all the Fanuc models we can, compared. We have the similar comparison with the different makes of the robots. So in case of the joint one, what is the the rotation or the degree per second of this particular robot, joint 2, joint 3 up to the joint 6. So similarly, we gathered all the data from their specification sheet, and we tried to find out the total number of the samples, total number of the per peak required. So the total number of the joint one moment required is 3600, and average rotation of joint 1 degrees 300 degree we got, in on an average, which is basically less than the actual moment. It can go up to 340 degree as well, the entire J1. So in a way, the variant selection, the robot selection, robot speed at each joint, and how it's a pose repeatability, point repeatability, and other function like how the grippers you are going to make. So all those things plays a very vital role, elemental role in case of the designing solution. And of course the visualization is again very important parameter. So I would suggest rather spending any cost on the hardware visualization or can be done in the digital software, robot design can be done in the digital software, and the application design can be done in the digital software. So probably preferring a digital version of this entire robot system would first of all beneficial to save the cost, and later on the cost can be invested for the actual application design, and which can be further miniaturized as well. So these were the our learnings from my 1.5 year of the project, and doing the 3 proof of concepts for this entire application. Now still there are the certain lackings. We are now integrating those lackings, like I have to run my simulation for 1200 samples. I have to run my proof of concept for 1200 samples. I have to generate the delay time, failure of the my programs, or efficacy of my programs. All those things I have to study. So those things we are doing in parallel. Now I am open for any of the question answer round. Please feel free to ask your questions.
Thank you, sir. So all participants, any query, any question, unmute yourself and ask questions.
Or if you are allowing me 5 or 10 more minutes before going entering into the question and answer format, I can show the robot analyzer software as well, which would be the play around for your participants as well. So how you wish, please let me know. I'll do that.
Okay, sir.
Sir, I think you can show that video, and then we can start with the question and answer.
Sure. So just allow me a
Sure, sir.
minute.
Yes, Ganesh, sir. Any questions, sir?
And though it is free of cost, I'll share it with all of you to, I mean, make the exercises and practice. So it's not a very tough one. Initialization of the robots can be done with this. I mean, people can start experiencing such things. I'm just sharing. Allow me a second. Yeah. So the good part is like you can see the Robo Analyzer. It's a software developed 15 years before. I think in IIT Delhi, Professor S.K. Saha, and still it is very relevant, and people are using it frequently for the initialization. Let's say in robot, what is very important? So the important part when it comes into the picture. So you have to figure out basically first of all what are the parameter of the robots, basically what you are going to handle. So that is very important. And in that case, let's say this is your robot. So what you are going to do first of all, you are having how many joints you are having, so which one is the joint one, so people can exercise this. So now joint one is moving, and up this can go up to this number of the degrees, right? So once you are doing this activity, you would be able to identify your exercise entirely to design your work envelope. So this is the second activity basically. But this type of the movement may not be permissible in your action. You have to change your basically the joint angles also. And all those joint angles may not be in the similar fashion. So you have to make a perfect envelope for your robot work. How your robot will work or how your robot will not work. So let's say if these are the joints are given to you, would you able to make a work envelope? Can your robot work like this? Probably no. Anyone can say that your robot is not going to work in this way. Yeah, Ganeshji, you are having some question. Mr. Ganesh, you have raised your hand. Please let me know. Okay, I think is not there. So here you can reset the curves, and then you can start first of all, joint number 3. So this is your robot extreme height. And here you can now. What is again important? So now joint number 2. So this way. So this is the joint number 2 entire envelope. And now coming to the point when it is joint number 1. So if your robot is able to make the joint up to this level, this would be able to identify your work envelope. Whatever you are designing to do the work, it should be within this envelope. And from the end effector frame, you would be able to find out its homogeneous transformation as well as the X, Y, and Z value. So this is the one activity you should do while considering your robot or making your robot, that it should span up to what I mean dimensions near and around the peripherals. So this is the one activity. How you are going to do after getting this, you will get the virtual robot. Hello. Yeah. So after doing this, then you have to go over here. You have to find out, let's say 1 degree of freedom if you are applying. So this type of the things will come into the picture. So this is the prismatic joint. You would be able to find out either prismatic joint or the revolute joint. So now this is the revolute joint. So in this revolute joint, so there are the things whether forward kinematics or the inverse kinematics. Let's say if you are delivering it for the forward kinematics, so it will take the entire steps to showcase you the forward kinematics. So this level of the variation, up to what level it can go. So simultaneously, if you go for the inverse kinematics, so you would be able to find out all the values of the inverse kinematic. You should be able to select the robot, let's say 2R planar robot if you are considering, then how it will behave. 2P planar if you are considering, then how the values will come into the picture. So those things you would be able to identify if you are planning for the inverse kinematic of the robots. Here, this is the simulation panel, and then coming to the graph value. So how your graph is identified basically. So in case of the graph, you need to select the first of all, let's say in case of the 3D model, and I think, yeah, first of all, you have to simulate some values, forward kinematics, let's say some values simulated. You can see how your, I mean, let me do this activity again. In case of the forward kinematics, so this is two joints are moving simultaneously. This is the line. But let's say if you need to check this, change this joint angle basically. Let's say if you want to make this particular things to work on the 60 degree. So now you would be able to see that how where your joint of the robot is basically acting. And let's say if you are going to change this to the -90 to let's say -60 degree. So again, you would be able to see how your application is going to be derived. Let's say I'm generating its forward kinematics curve. You can see, but let's say simultaneously, if you are stopping and if you are trying to make, let's say this as a positive 60 degree, you can see if you need any application to be extended at this level, at this particular angle, you should be able to do that. So these are the some basic things for the your robot design. I am not dealing or going into the depth of its mathematics because it is a too time taking process. But yes, I mean in case of the visualization manner, how you can do this differently. So this was my primary things to target. Now there is a software called Robot software. You can go and use that. That is a free of cost for the students. You can, I think, go for the Python, that is free of cost software. You can use Simulink as well, as that is a free of cost software. So before going into any other detail, let's say if I'm going to target, let's say 6 degree of freedom and 6R robot. So this type of the robot will come in front of me. And let's say if I need to simulate it for the forward kinematics, you just try to observe that how my motion is planned. So how much area I would be able to cover, what type of the trajectories I would be able to make that, So all those things you can plan. If you are having six robot, if you are having the I mean Stanford, that time it was the very standard robot of the Stanford robot, which is named as the Stanford. This is very I mean good for the exercises to learn the fundamental of the robotics. So it's a forward kinematics. Now if you are playing, it's a forward kinematics. You can see how it is moving and how it's all the axis is trying to vary. Here also you can change. Let's say if you want to design your own robot, if you want to change this joint type, you can change your joint type. So all those things you can plan and you can do the experimentation before going investing any of the heavy value infrastructure. Yes. Now I'm open for the question answer session. Please let me know.
Hello, sir. Am I audible? Hello. Hello.
Yeah, you are audible. You are audible.
Sir, can you suggest some books to start robot programming or at initial level, beginner level?
So, I mean, I would just suggest that before going for the book, you try to find out your interesting story in RoboDK or any other freeware. So, you will start the fundamentals and then you can go to the books. And in case of the books, I would suggest there is a very John Carg one book is there and Introduction to Robotic Fundamental. Just allow me a time. I'm having and I'm sending it to you. Dharmik sir, am I allowed to send the books?
Yes, sir.
Thank you. I think in chat books are not getting loaded.
Sir, you can send it to us. We're going to actually send it to the all the delegates.
Sure, sure, definitely, sir. I'll do that. Meanwhile, I'm having one textbook. It's a KS4. This also you can use KS4. It's a very simple book basically. And there is a book by I think John, Modern Robotics. Modern Robotics and Introduction to Robotics and this robotics basically. So these three books would be more than sufficient for you to get the fundamentals of the robot. It's a very little bit of mathematics oriented, but by the practice or by including that mathematics using modern technology, you can use Google Lens to take the photograph of that and finding the solution. If you are finding, it's very much mathematics oriented, and if you do not have solution with anyone of around you, you would able to get the solution by that method as well. And even you can denote those parameters of the questions to the Python to solve such scenario. That will also help you. But my objective is to not getting you the solution. But only thing is that to if you are able to find out the solution of any problem, you would be able to I mean get into by learning of that. Otherwise, what will happen? You'll lose the interest. If you'll not start finding the solution, the losing of interest would be very I mean I mean, it's for us also, we are losing the interest if we are not finding the solution. Sometime happens.
Okay. Thank you, sir.
So, Abhay, you asked me, sir, can you please move on the first slide of your input details yours, if it is possible. Yeah, I can. I think my detail is related to. Uh, yeah, is it? If it is required, I can place it again. 1 second. So, Mr. Abhay, are you able to see this? So this is basically my details, and my email ID is also written over there.
Thank you, Shukla sir.
Thank you. Yes, please.
I think, sir, no question for participant.
Dharmik, I think there is one question that is, please share your opinion about the effect of automation and
Okay.
robotics on employment.
Uh, Please share your opinion about the effect of automation and robotics on employment. I mean, very good question, Dr. Prathmesh, right? Yeah. So, in my opinion, and the fact which I have seen across the industries is like automation and robotics to enhance the humbleness of the job. It's not to take away the jobs. See, only the difference is that, I mean, I had attended one presentation, I think in 2016 from very famous book in mechanical. The author of that book, I mean, I'm just forgetting the name. Probably I'll remember. I'll tell. So what was the situation? It was situation like that when the computer age will come, what will happen? So it's like a pushing a boundary. I mean, you may reduce the number of employees in the banks, but to operate the banks, you may need to add n number of the employees. So you are taking people out of the bank, but enabling the banks to do along with them. I think this may be the very easiest example to understand. So similarly, in the industry as well, you may be pushing people out of their floor, but to run that floor, you need those peoples again from outside to support that. So you are only evacuating the floors, but yes, to maintain that floors, you are chartering the different number of the peoples, different skill set of the peoples. So that's my opinion. It's not to reduce the job, it's basically increasing the job. Because to make one thing functional and to make one thing advanced, to give autonomy to any of the machines or the robotic system, a number of the things are required, which gives the, I mean, jobs basically to the people of the variable skills. So I'm trying to look into the chats. Okay. Yeah. No. Can you see the robots application of robot in agriculture sector? Yes, I mean robotic applications are there. May not be the six-axis robot. It may be the humanoid or the other robotic function. One thing I would like to make you understand that one you may be saying that these drones are basically used in the agriculture. Of course, it's a kind
Hello.
of the yes,
Sir,
yes, Manoj sir. Yeah. So, Dr. Amit, I mean, things are there. I mean, the drones basically used in the agriculture, but we have to go by the definition of the IEC or the ISO, basically in the International Standards Organization. Because I mean, there it may be possible that drones may not be coming under the direct category of the robotics. Of course, it's one of the application, it's one of the way to engage, but we have to see about the definition whether it is coming under that or not. Of course, direct application of the mobile robots are also there as a weed remover, or the direct application of the laser hitting of the weeds are also there. So this is the. So any course offer for robotics in your organization? Abhayji, I mean, we are opening the school of robotics where post your, I can say the graduation, the courses would be there. I mean, information is yet to be floated in public domain, but very soon it would be there. Which AI is used in this and can be used in supply chain to make it smart? In supply chain, basically, you can use this ASRS system, and there it's which algorithm of AI is used. I'm not able to comment on that. So, but yes, India is moving very fast in the, I can say, the supply chain management. So those things are there. Adverb is a company which is making the, I mean, this warehouse management systems. Few other companies are also there in India. They are making the ASRS system or the warehouse management. In warehouse management, I can give the two robotic terminology. One is the AGV and AMR, autonomous guided vehicle and autonomous mobile robot. So that may be helpful for you. But when it comes to the exact AI which they are using, I'm not aware of that. Any other question?
So any questions from the participants, they can please unmute themselves and they can ask. Or we should move on. I think so. There's no more questions.
Thank you.
Okay.
Okay.
Dharmik,
Move on.
please, you can move on.
Yes, sir. Thank you, sir. It is very insightful and engaging on topic of role of robotics in manufacturing and industry 4.0. Because, sir, it is a generation of artificial intelligence and machine learning. This topic is very, sir, useful for us. Thank you very much, sir. Your expertise and valuable knowledge have truly enriched today's session. Thank you very much, sir.
Thank you so much, Dharmik ji, basically, Manoj sir and Vishwesh sir. So thank you for
Thank you
giving
very
me an
much.
opportunity to share my learnings in, a very specified manner. And of course, the ease of work was like attending the talk from, giving the talk from your home location. Sometimes it may be disturbance. I'm apology for that. It would have been created a little bit noise from the background. So kindly excuse me for that. But yes, I'm grateful to all of you for the opportunities to talk on this platform. Thank you.
Thank you very much, sir. I think it's a great opportunity for all the participants, delegates, because they are all attending from their home.
Yeah,
So,
right.
so it is a
So
great initiative by AICT, and I think we should acknowledge them. Thank you
thank
so
you,
much,
sir.
sir.
Thank you so much, sir. Thank you so much.
Okay,
So one
thank you.
Yeah,
last
thank you,
question
Dr.
is,
Ashish.
thank you, sir. Thank you so much. One question is, what is machine learning used in the mechanical field? So machine learning is basically, so one thing, what the way you are learning, machines are also started learning in the same way. Only you are having your own thought process of learning, whether it may not be taught by anyone. You are having your own sense, but machines, you need to give them thought. Like you need to make them understand the algorithm. You need to make them understand that how they should operate, how they should learn. So basically, the algorithm like the CNN or the deep learning, so these type of the neural networks or the other type of the I can say implant in the machines are required to learn. So basically, you have to put the brain to machine to learn it. Basically, that's as simple as that. And in fact, nowadays you need not to learn a coding as well. ChatGPT or any Copilot or any other domains are helping you, because in fact the CEO of NVIDIA is itself or themselves is saying that You need not to master of the codings. Coding will help you. Just you have to sort out the applications.
Yes, very truly said, sir. I think before moving on, I request all the delegates to please switch on their video so that we can have a common photograph with sir. Requesting all the delegates, please switch on. Requesting Dharmik, can you please click on?
Yes, I take photographs.
Sure. If you are finished, please let us know.
Yes, sir, it is finished.
Okay. So thank you, Ashish sir, for accepting our
Thank you.
request and giving your expertise and valuable knowledge to enrich this today's session. Thank you once again, sir.
Thank you, sir. Thank you so much for inviting me. Have
Thank
a
you,
great
sir.
day.
Thank you very much, sir.
Thank you, sir. Thank you.
So
Thank you,
moving
Shukla sir.
ahead, okay, moving ahead, we have another expert session. Now I would like to invite Mr. Piyush Patel, an assistant professor at R.K. Desai College of Education, VNSGU, to introduce our next speaker, Mr. Nimesh Chinoy, sir. Piyush, are there?
Yes, sir.
Okay,
Am I
thank you.
audible?
Over to you.
Okay. Am I audible, sir?
Yes, you are audible, please.
Good evening, everyone. I, Mr. Piyush Patel, Assistant Professor, R.K. Desai College of Education, Vapi, Valsad, affiliated with Narmad South Gujarat University, Surat, Gujarat. Today, I am going to introduce Mr. Nimesh Chinoy, sir, has already delivered a compelling lecture in this FDP on the topic demystifying implementation of Industry 4.0 for welding in manufacturing setup. Today, he will continue his discussion on the same topic, further delving into key insight and practical applications. For those who may have missed his introduced earlier, Mr. Nimesh Chinoy sir is dynamic leader and innovative thinker and prominent figure in welding science and technology. With 21 years of experience, including 4 years in research and development and 17 years in projects, sales and marketing, he has significantly contributed to advancing welding technologies in India. He currently serves as the director Sigma Wed Electronic Device Worldwide Private Limited, along with holding leadership roles such as honorary secretary of the Associated of Welding Products Manufacturers of India, IIW, Central Council representative and members of the ATD 21 Sectional Committee of the Bureau of India Standards. His contributions span critical national projects including the Gangayaan mission for ISRO, Chandrayaan 2 and 3 and key nuclear energy and aerospace project. Mr. Chinoy is also the visionary behind the WellTech Talk, an international platform with over 36 experts lectures and participants from 24 countries worldwide, with numerous accolades including the Dynamic Young Entrepreneur Award, the 2022 Make in India Award. Mr. Chinoy continues to inspire through his dedication to innovation and excellence. Ladies and gentlemen, let us welcome Mr. Nimesh Chinoy sir to continue his enlightening session on the demystifying implementation of Industry 4.0 for welding in manufacturing setup. I hand over to Mr. Nimesh Chinoy sir. Over to you, sir. Thank you.
Thank you very much, Piyush bhai. By the way, I'm now in Vapi, so good to know that you are from Vapi, and maybe sometime later we will connect. I believe in the last session there was a question just at the end of it that was about how do machines learn or how do you make it learn. It happens to be one of my favorite topics. So I'll just give you a 2-minute insight into neural networks. So like you have your brain, it's made up of neural networks. There are different nodes in your brain and there are links between the nodes. So we write a program in which you write algorithms to weight each and every node. And then the link between the two nodes is called the weightage. When you then start teaching the neural network with what is right and what is wrong, like you do to a child with a new memory. So you tell them this is good, this is not correct, this is correct, this is not correct. So the more you feed data to it, the more it learns that data. And then when you give them a fresh piece of data, it will try to analyze that data on the basis of the previous data. It is based on the weightage of the nodes and the node algorithm itself. On that basis, it can take a decision for you, which is in line with what you have taught it before. So if you told the neural network that 2 plus 2 is 5, and you kept telling it that is correct, then every time you show him what is 2 plus 2, it may give you 5, it will not give you 4, because that is what you taught the network. So always remember, with computers, junk in, junk out. What you give in is what you will get out, right? Now jumping back into our topic, let me just share my screen. This is, I hope my screen is visible now. Is that visible, sir?
Yes, sir. Your screen is visible, sir.
Thank you so much. So this is where we left off yesterday. I hope to continue from here. Just a brief checkup on what we were to measure and how to measure in terms of welding. And we had discussed about various sensors that you can use to capture this data. Critical data in welding happens to be the welding current, welding voltage, the gas flow in case you are using MIG or TIG welding, then you have gas flow, wire speed if you are using submerged arc welding, cold wire feeder for TIG or MIG, any kind of wire that you feed, you can take that. And then there is welding speed, that is the speed at which the welding is happening, and job temperature in case that is critical. Okay. Now we discussed the different types of sensors: current sensors, shunts, gas flow switches, mass flow controllers, optical pyrometers, K-type thermocouplers, and encoders. So this we had already discussed. This is a CT, it's a current transducer which measures current, and it gives you the output in terms of 0 to 10 volts as a feedback. This is a shunt, it usually gives you a feedback for voltage in 4 to 20 milliamps. Here you can see a digital gas flow switch and a mass flow controller, which will allow you to control the gas flow pressure and also calculate for you the actual amount of gas consumed. These are different types of temperature sensors. So this is a K-type thermocouple. This is the bare wire of the K-type thermocouple. This is when the junction is made. This is where the sensing happens. This is an optical pyrometer. It will sense the digital, the record of the temperature digitally. And many of you might have seen something like this, an handheld gun, but this is distance driven, it's laser based, and it also cannot give you feedback into your machine. So usually you need something like this, an optical pyrometer or a K-type thermocouple, to connect back to collect the sensor or the data. These are encoders which are used for motors to sense their rotational speed, their linear speed, etc. Now we came into how the welder can log in using either an HMI for username, password, using fingerprint readers to share their presence, RFID cards or NFC cards. These are the different ways of doing it. Most effective are the RFID and NFC cards because they can have more than one data encoded onto it. The TPM data that needs to be done. So first of all, most of you, are you quickly, if you can mention on the group, do you know what TPM stands for? Okay, I couldn't see here. Can I see if anybody knows what TPM stands for? TPM.
So total productive maintenance?
It's total production management. Okay, so basically, when you are doing any kind of production, the time spent on any activity that you do is measured, and that time can be either productive or non-productive. When it is a non-productive time, if you know how much time is non-productive, you can capture that time and then you can take an action on it. So what do I mean by that? Let us see. So if you have data which is productive or non-productive activities, in terms of welding, if you are changing any consumable, that means you removed the spool and you put a new spool, you change the tip of the torch, you wanted to grind the tungsten, you went to bring up the electrodes that are empty. All these are activities which are necessary. You cannot get a good quality weld without this. So they are necessary, but they are non-productive. They are not helping you produce. So you have to do something to reduce this time, but you cannot avoid it. Similarly, you have lunch break, tea break, shift change break. These are times you will know when there is no activity at all because there is a clear break. Then there are personal breaks, loo break, for example, somebody wants to go to the washroom. So these are breaks which are avoidable or plannable. And then you have got machine breakdown. So this is critical. So if there is a breakdown in the machine, you will not be able to weld at all, right? So how do you want to measure that? Job shifting. So suppose you are working on a particular job, the job needs to go to the furnace, come back from the furnace, it's going for machining, coming back from machining. So this shifting, edge preparation, etc. is the time when your welding machine is idle. It is not working. So you are doing all this from a point of view of the utility of the welding machine and the welder. So the welder or the welding machine at that time is idle, but this is a critical requirement. So you cannot avoid it. You have to find a way to reduce it. So these are some of the examples that we did for a customer. So a welder may be not working. Every time he switches on the machine to the machine will ask him to choose one of the reasons why the machine was switched off. So the operator will say there was no work schedule, machine was under breakdown, it was under maintenance, there was a meal break or a tea break, there was a bio break, there was a long break, there was no operator present. Uh, there was some unforeseen reasons like electricity wasn't there or some accident has happened. The job is under preheating, so there is no welding happening. The job is under cooling, so there is no welding happening. Tack welding is going on, so this machine is not being used, it is used for full welding, so again no welding is happening. There is no grinder, so unless the grinder grinds the edge, I cannot weld, so again the welding machine is waiting. It is waiting for the crane. These are classic shop floor problems. So you have one overhead crane which is moving the job from point A to point B and it is doing multiple other things. Till the time the job comes there, the machine is idle. So why it was idle? It was waiting for the crane. There is preparatory work is going on. There is no assistance or any other reason. So once you are able to capture this data, you can analyze at the end of the week, end of the month, why this was not, how much time was spent on each activity. And if you see from these examples that there is a many number of times there is no grinder, then the shop floor person knows that if I add one grinder, I can save 3 hours of time in a week and convert it to welding activity. So they can request to get one grinder in place. If they see that, for example, there is no operators for a long period of time, then they can go back and say, look, we are short of welders. If we have more welders, we can use the resource better. If you see that there is a consistent, so I'll give you a very live example. In one company where we had done this for about 40-50 machines, they were able to analyze at the end of the month that one welder is gone for 15 minutes permanently, every day before lunch. And they wondered why there is a fixed 15-minute break. So because the record was there, they called him and they asked him, every day you are taking a break between 12 and 12:15. Why is that? So he said, I'm a smoker and you have put me on the last bay. So I have to walk outside the full workspace, go outside, have my cigarette, then come back into work. This takes me 15 minutes every day. After knowing this, they made his shift closest to the exit. So his break time became only 5 minutes. He goes out, smokes a cigarette, and comes back in 5 minutes. They were able to save 10 minutes of productive time because they knew that this is what is going to happen. So once you collect the right set of data and analyze it, you will be able to use it for improving your productivity. Now, how does a data monitoring system or an IoT system work? This is a welding machine example. Any welding will have terminals, positive, negative. The sensor box will be connected to these terminals. From these terminals, you will connect again your electrode holder, welding torch, etc. and then do your welding. When you're doing welding, the sensors are sensing the data and churning in the data. And when you stop welding, the data is then either saved here for you to take out using a USB, or it can be sent onto the server. Now, this is for a single machine system. This is an external box called the data monitoring system. It can be connected to any welding machine. It can be of any make. And you can connect the system. The sensors will be chosen on the basis of what all data you want and the capacity of the machine. If the machine is 400 amps, 600 amps, 1000 amps, accordingly the sensors will change inside here. It will record the data, and then you can take a data dump on a pen drive. If you had many machines in a shop floor, suppose you have more than 50 machines on a shop floor, then you connect uh, each machine to a small sensor box. It will just collect the data. They will share this data with something called a collection unit, and then multiple connection units will send the data to the server, and then the server you can access, analyze, and see. Now here the data is collected physically from the machine to the sensor box. From the sensor box to the collection unit, it can either be, multiple machines connecting to one collection unit, can be either through LAN or it can be through Wi-Fi. Similarly, from the collection box to the server, this can be through LAN, it can be through Wi-Fi, or it can be through GSM. We will see each of these examples of why to choose or what methodology to choose when. Now, your shop floor can be of different types. So for example, if you have a automotive shop floor where the workstations are fixed, so the operator, the welding machine, and the workstation is fixed, the jobs will keep coming to the operator will weld and he will put it away onto a bin. So operator and the welding machine are not moving from their place. The job is moving. There are small components constantly moving. These kind of setup have got a very fixed layout of welding machines. So the best way to connect them is using LAN. So you can have 20 machines on the top. You use a LAN cable to connect all 20 machines. That can go to a router, and from the router you can have one LAN cable, LAN switch going to the server. This way, there is no loss of data. This is the cheapest way to do it because LAN cables are always going to be cheaper than using multiple Wi-Fi routers. So this is one way of a fixed station multi-machine setup. It can be manual, robotic, or SPM setup. As long as it is fixed in a place, you can connect it using LAN cable. Then there are bigger components, for example, pressure vessels or girders or cranes. When you are manufacturing these kind of components, you cannot keep moving the component from machine to machine. Machines go closer to the component. The welder has to go to closer to the job. Now, in this case, you cannot have the LAN cable running around everywhere. Therefore, you have to connect the machine to your server using Wi-Fi or GSM. Now, if your shop floor is has Wi-Fi connectivity, then it's better to use Wi-Fi. But suppose you don't have Wi-Fi connectivity and your machine is working on site, suppose on a railway yard or on a bridge being constructed, then you can use GSM, that is a SIM card, inside this data monitoring system, and it will throw the data on a protocol called MQTT. And MQTT will transfer the data from the machine via SIM card to the satellite, from the satellite back onto your server on the cloud or on a physical server, and then the data will be stored there in the database. Then you can use your interface to see the data. Now, how are the configuration or how does the flow look? If you were to use a simple way, The power source would have connected to sensor box. The sensor box will have isolation cards to protect the PLC or the microcontroller. Then the signal is shared to the PLC microcontroller. The PLC microcontroller will have an HMI or a human machine interface wherein the user is entering data. He can see the data. And from this data, he can either take the data out using a USB, or he can decide to have a wireless connection to a cloud, to a data access point, to remote monitoring points. Or he can take out the reports from the HMI itself using a pen drive, which would be an arc on time report or a weld analysis report. Now, the same thing you want to do, but you want to have the welder information as well. So the welder will use an NFC card or an RFID card to log in. When he logs in, the power source will connect to the server. And from the server, it will send out the information that the parameters for which the power source should weld. Then during welding, the sensor box will capture the data. From the captured data, it will use an isolation card to, isolate the signals, send them to the microcontroller or to the PLC. From there, through serial connection and an MQTT box or an inbuilt Wi-Fi router, it will be shifted to the server. In the database, it is stored continuously. From the server, you can use an interface software to take reports which are name based, which are time based, or which are machine based. Now, if you have a two-way communication in this system, you can use the NFC card from the server. You can put data onto the NFC card as to this operator has to weld at this parameters. Once the data is on this card, when he swipes the card on the power source will get the data within which it should work. Then that data will be captured. It will not allow to move away from that data. Captured and verified and then stored in the server and then seen by the operator or the professor, the supervisors. This is the interface for a single station. You can see welding voltage is in volts, welding current in amps, wire feed rate in inches per minute, millimeter per minute. Arcing time, the red one is the interpreted data. Here you can see wire deposition as an interpreted data. And in the data entry, the operator may have to put the job number, the job diameter, the operation number, wire diameter, wire speed, and well pass. These are data that is physically entered. And he's choosing the wire type. So this is 70S6 and it will say it has got 7.88 grams per cubic meter density. So using this data, the system can calculate what is the wire deposition. Correct. Later you can choose the date and time from where you want the data to be uploaded onto the USB. When you press USB upload, it will put the data onto the pen drive. Now, the advantages of IoT protocol are that the data collection from welding machines placed locally or anywhere globally using secure and advanced IoT protocols. Real-time statistics in graphical format can be seen on the dashboard. Reports in tabular as well as graphical format can be seen. Configuration and classification based on project ID, job numbers, welder IDs, and welder identification through RFID or USB devices can be done. Now, here is another typical implementation where you have an HMI card, HMI screen. The welder switches on the machine and asks to swipe the RFID card. Till you swipe the card, you can see there is no voltage, no current. It shows that this machine has been on for 3 hours, 3 minutes. It doesn't have any minimum maximum voltage setting. And it says the DMS code is 123456. So as soon as the welder will swipe the card, he will see this screen, which will say enter your DMS code. So when the welder entered the DMS code, it says, okay, this welder is logged into this machine. Now, when he did that, it will be asked why the machine was under breakdown. As we discussed, why was it off? He will choose one of the reasons. Then it will say you are ready to start. And it has automatically pulled out the data. You are supposed to weld at 15.7 volts, 180 amperes. And the range in which you are going to weld is 13 volts to 33 volts. So you are within the voltage range. And the ampere that you are supposed to weld is between 113 and 333 amps. This was the range defined by the customer. And they are welding at 138 to be the minimum amps. When the welder is welding, the data will start capturing. Later, this data can be seen on the server software. This is the server software. On the server software, on the left-hand side, you have all the welding machines. Then you have data of the operator and the welding machine being used. What is the current voltage? So here you see a green dot and a lightning mark. This shows you that the welding machine is on right now and it is welding. If it is a red dot, it shows you that the machine is switched off. Okay, you can see current voltage graph and you can see the shift wise performance. I will show you the live data of this in some time. Now this is what I was explaining to you. On the left hand side, you could see machine number. If the user is logged in, you can see the name of the user or the welder, and you can see the parameters at which it is being welded. Okay. Green with a lightning shows the welding is on. Green means machine is on, welding is not on. And red means machine is offline, it is switched off. This shows you shift-wise data. You can define one switch, one shift, two shift, three shift that you are working on. For each shift, cumulative number of hours are available to you, 30 hours, for example, for 2 or 3 machines. And it will tell you if you welded for 3 hours, 48 minutes out of 30, your arc-on time is 12.67%. So this is your efficiency of usage. You can clearly see in one screen itself. Then it can show you each hour what was the utility. Now reports you can have on the basis of time, welder, project or TPM losses depending on what you have put. If you choose a time-based report, you can say between this and this date, please show me all the machines that were welding, what was the time taken by them, and what you give me a machine time-based report. 1 week, what is the report? Then you can say, I know I only want this welder. Give me the full report of this welder for the whole month. So it will give you a welder-based report. This can be a machine-based report as well. This machine full month, what was the utility it will give you. Similarly, project-based report. So project-based report means if there are multiple machines working on one project and you had entered the project name in every one of them, then you can choose a project number and it will give you all the welding machines that were working on it from this time to that time and what was the parameters at which they were welding. Last is the TPM losses report, in which you will see which particular productivity activity, what was the downtime and which was the one that was repeated the most. Okay, this is how you can choose machine 1, time based, this date to this date. And then you can select the time and you can say download the view. It will show you a tabular format. And the same thing you can see in graph as well. So this is you can download this as a non-editable PDF. So you cannot edit it. The data cannot be tampered with. And the number of digits you can control. So you are having 9.8, but here you can see 9.8, 14144. So you can control the number of segments you want. Now here I have chosen Abhijit Naik as the welder and I wanted to see the report. What did he do on 3rd November 2020? And it can show me he was using this particular machine. This was the welder between this date, this time. He welded for these many seconds at these parameters. 1 second. Let me come back to you. 1 second, please excuse me. प्रतीक भाई एक मीटिंग में करो कॉल. हाँ मोकलाओ एक सेकंड. Just give me 1 second. Please hold on a second. Please give me 1 second. I'll just come back. Sorry for the break, but this is a problem when you're working from home. Okay, so you can have a welder-based report which shows you what the welder was doing throughout the timeline. Similarly, we can choose project-based. I've selected a machine. I can choose project-based report. And here you can see the name of the company, the project it was working for, the particular joint number, drawing number, process, WPS number, program number, different machines used, welders used, and time between which it was doing the welding for this project and the parameters. So this gives you a lot of insight into what was required or what had actually worked for a particular project. Similarly, you have a report for TPM losses. Here you can see that, okay, the reason for breaks on this particular day, Abhijit Naik took 2 breaks, which were for maybe 12 minutes, and they were bio breaks. And then Naved took 2 breaks, which were hardly 1 minute each, and it was for a loo break or whatever they wrote for it. This was the time at which they took the break. Here you can see cumulative record of all machines, hours, days, month, year, custom type reports you can get, right? Again, you can take a different kind of tabular report machine. Each machine they'll show you. You can do a comparison arc percentage. You can have, hour versus minute, deposition rate, depending on your requirement. Once you have the data, any kind of analysis can be done. So what analysis is important to you? If you mention that, you can have a report similar to that. You can choose shifts, each shift that you want, shift 1, 2, 3. You can check first shift, what happened, how much was my arcing time in the first shift, how much is my arcing time in the second shift, how much is my arcing time in the third shift. As we discussed yesterday, this is what is important from the production guy viewpoint. So all this you are seeing is from the production viewpoint. And you can have, again, monthly reports of comparison arcing hours per minute per day, right? And then the shop floor will know total. I had, say, for example, I had an ability to do maybe 100 hours, but I have only used my shop floor for 27.5 hours of arcing. So I have a potential of another 72 hours that I can do welding. I can take up more work. Now this is for the operator. You can choose which welder was present, how many days, how much was each welder welding. So you can have a comparison as to who is your most optimal welder, who's given you most productivity throughout the month. And you can see which welder has been least productive. You can have similar reports for welder wise, reasons for TPM. So each welder, what is their break time and why? So if there are larger breaks for lunch or this, you can probably highlight it to them and bring that time down. Again, project wise, if you wanted to see if your equipment was used for which projects and each project, what was your arcing time, it will tell you all the data. Each new machine you add, you can configure it. It needs to be given one particular IP address. You can give a machine name and you assign a particular TCP port to it. And then that is what you will see on the left side, it being named as. Here you can have very smart names for your machines, which tell you where or which project they are working on, which pillar they belong to, so that you have better analysis of your work. This will be shift-wise report, first, second, third shift you can configure. Suppose some companies work 7 to 3, 3 to 11, and 11 to 7 in 3 shifts. If you're working 2 shifts but 24 hours, then you will not have the third shift. You would say I'm working 7 to 6:59, 6:59 to 7. That would be your 2 shifts. If you work only 1 shift, you would say I work 9 to 5:30. Then you will have only 1 shift. You can configure this shift. You can configure your breaks that, okay, we allow 2 breaks in a day. Lunch break is 60 minutes, 15 minutes tea break. So total you get a 90-minute break. You can define that here itself so that when you are calculating, those breaks are pre-calculated. Every time you add a new welder, you can add as much data as you want on the welder. You can add their qualification, their certifications, their name, age, where they were qualified for, where they were last used, where they have worked, any kind of information that will help you assign work to them, you can allocate it. So this is how you can configure, you can give them operator IDs, things like that. You can also add the RFID code here itself. So if you are using RFID, you will have an RFID code for each, assigned to each welder. Now you can have project details and you can have other details that you want to put in. Now, if you define a new project, you can say, okay, this is the project name, project, you can give it a code and describe the project. Later, you can add or configure the particular project. So for example, if I say edit, I can say this job number, ABCD, this is the DMS code, this is the project name, this is my internal drawing number, I can have which process to be welded, what is my WPS number for this, what are my WPS ranges. So it will say your consumable should be this size, your voltage should be this, minimum maximum voltage, minimum set current, maximum set current. Once you save this, whenever the welder will select this DMS code 222222, this WPS will automatically be loaded onto it because this is what you have configured it today. So if you tell any welder and you will tell him your DMS code for the day is 22222, when he goes and enters the DMS code, this data will automatically be loaded. So you don't have to tell the welder what parameters, isse bahar mat jana. It automatically controls the welding output. Here you can define everything for a new project, a joint number, DMS code. Code will automatically be generated for you. The rest of the things you have to enter. Then you give this printout to the welder that, okay, this is your code for the day and you have to only work on that code. So welder is assigned, everything is done on that basis. Now, if you have any questions, I can answer them right now. After this, I'll show you a live, uh, website where 50 machines are working. So can we take some questions right now, if there are any? Any questions at this moment?
Okay, the participants can unmute themselves and they can ask the questions.
I think there are no questions.
Yes, there are no questions. I think so.
Okay, no problem. So is my screen visible to you right now?
Yes, sir.
Okay, this is a live example of a company where about 50 machines are connected to the cloud. So I'm going to log in here. So there is a password protected login. So once you log in, you come to the dashboard. This is the dashboard. Now on the dashboard, you can see there are total 47 machines. 2 machines are online, 45 machines are offline. Okay. Of the machines that are online, both the machines are flux code machines. And you can see here the full range of machines. Okay. And if I say, okay, all the 7 SAW machines, they are all offline right now, as of now. Okay, here on the left hand side, you can see the dashboard. All red dots means offline. Green dot means they are working. So let's see what is this machine, but they are not arcing because there is no lightning sign next to it. But since this is on, let us just see this machine number 67. If it was welding right now, you would have seen the welding voltage and welding current parameters here. Here you can see that the machine has been used in the first shift. This is only a 2-shift company. So first shift is worked for 6 minutes. And in the second shift, it's not yet started. So total arc-on percentage is only 3% utility in the first shift today for this machine. Let us see today, 12 o'clock it started but did not weld for more than 5 minutes. 8:30 in the morning, 9 o'clock, it welded for 3.83 minutes. 10 o'clock, they welded for 6.7 minutes. 11 o'clock, they welded for 3.5 minutes. Then again at 2 o'clock, they welded for 20 minutes. 3 o'clock, 7.6 minutes. And then again 5 o'clock, 3.16 minutes. So this is the utility today for this machine so far. After 6 o'clock, 5 o'clock, the shift change, probably they have not had the second shift today. It's not working. Correct. Let us take up any other machine which is switched off. Say this machine, for example. Now this machine welded for 1 hour 44 minutes in the first shift, which is about 14.5%. So when did they weld today in the first shift, and what were they welding? So you can see they welded at 9 o'clock they started. 10 o'clock they welded for 4 minutes. 11 o'clock for 8.15 minutes. Now at 12 o'clock 15 minutes. Lunch break I am guessing at 1 o'clock. 2 o'clock 24 minutes welding. 3 o'clock 10 minutes welding. 4 o'clock 6 minutes welding. 5 o'clock 15 minutes. 6 o'clock 6 minutes. And 7 o'clock 12.6 minutes. So up until some time ago, this machine was arcing. Okay. And now it is showing you the full list of machines. You can choose any machine at any given point in time and try and see when was it used. So this machine was not used today. There is no activity on submerged arc I can see. Okay. So no activity on submerged arc, but for these machines for FCAW and MIGMAC they are using. Here you can see 3-hour welding today in 12 hours, which is a very good 26% of usage. Now, when he was using at this time, what was his parameters at which he was welding? Suppose we are interested to see that. So let us say we go to reports and we'll say, what kind of report do you want? I want machine-based report. Which machine do you want to see? Let us say we saw machine number 71. So I say I want to see machine number 71. Okay. Choose your start time. So I say I want to see from yesterday, 12 o'clock in the night, till today, 12 o'clock in the night. Can you show me the result? So it's saying this is machine number 71. It arced for 4 hours 25 minutes 50 seconds. Now, when did it start? It started at 8:33 in the morning. It arced for 12 seconds at 204 amperes. So probably he was doing tack welding most of the time. After putting 2 tacks, he put a full weld for 51 seconds at 208 amps, 26 volts. Then again, there was 1 minute welding at 8:37. Again, he welded for the same parameters, again, same parameters for 36 seconds. You can see here 1 minute, 48 seconds. So this machine has been pretty much used for full welding or larger tack weldings, right? And after every 1 minute, the welder has to stop for some reason and restart. Right? This means he's continuously welding. If you see here, 59 seconds, 59 seconds. So he welded continuously. So his welding started, it did not stop. So for almost 1, 2, 3, 4, 5, 6, 7, 8, 9 minutes, he was non-stop welding at the same parameters. Now, they have used only the current and voltage parameters. Had they used gas sensor, they would have had the gas flow and they would have had the weld deposition also had they used the wire sensor. They have not used those sensors, so they don't have that kind of data. Now, here is a classic example for you to see what they welded. And because they are already deciding what they want to weld, they will always remain within the range. They will not be able to go outside the range of welding. Now, if I wanted to see for the full month, I could say December 1st till today, show me what was the utility of this particular machine. And it's telling me I have used this machine for 45 hours, 1 minute, 29 seconds. It will give me all the details as I want. I can download this data and it will download it in terms of a XLS sheet. And this Can you see this report? Now this report tells me machine name, machine number. It's a day type report. It was from 1st December to 27th December. Total arcing time was 45 hours, 1 minute, 29 seconds, and it gives me continuous rating of all the readings that I want. If I just look at the number of data points we collected, it's close to 4,000 data points, 3,991. That is the amount of times it logged the data. And the sum of all the arc times will give you this 45-hour window. Right? Don't save now. Here I can say I want multiple machines. So I want machine 60, 70, 71. I want to see 72, 73, 74. I want the result of these 5 machines over this period of time of this month, and I want to view it. And it will show me the data of all the 5 machines. So probably the other machines are not being used so far. Let us select some other machine, say 53, machine 1, and I select the same time frame, 1st December till today. And I want to view. So it's loading the data. Now you can see machine number 1, all the machines that we selected, it has given you the data. Machine 1 was not welded at all, it's not used. Machine 53 is also not used. 70 was used for 1 hour 51 seconds. 71 was used for 45 hours. 72, 31 hours. 73 was welded for 1 hour 35 minutes. And 74 was welded for 42 hours. So this gives you a very clear insight. You can download the data. Now these are tabular reports. You can have graphical reports. And you can say, okay, I want machine type report. I want to choose machine number 53, 44, and 70. And I want the graphical report for, say, yesterday view. So here you can see, okay, machine 53 wasn't used. What about 44? You can see machine 44 was used 18%, 2 hours 16 minutes in the first shift, and maybe only 2 hour 22, 2 minutes in the second shift. First shift 2 times it was used, and the percentage is 18.9. Second shift it wasn't used. Here you can see the hour-wise breakup of utility. So majority of the work is happening at 9 o'clock when the shift starts. Productivity comes down post lunch, there's a gap, and then there are 2 large before the shift ends. And this machine only used for a very short time at the end of the day. So not really used at all. So this kind of graphical data or this data can come. You can have machine wise details. You can edit a machine. Okay, machine name, machine ID, type, subtopic. You can change the details that you want. You can add, remove a particular machine. You can edit your shift details. So you are here, they're using 2 shifts, 8 o'clock to 8 in the evening and 8 in the evening to 8 in the morning. If you had 3 shifts, you can add and you can say shift 1, 2, 3. Operator details, you can add operators as you want. And if you have more than one operator, you can assign an operator ID, an RFID code, etc. Here you can see name, operator, last name, and operator ID is the detail you can add. And then we saw the reports and graphical reports. So this is what I wanted to actually share with you guys and show you what a live example of IoT or DMS. Now I'm sitting in Vapi, the equipments are somewhere in Tamil Nadu, and I can see the parameters at which they have been used or they are using it, and I can analyze the data and discuss with them why or what is good or bad. Okay, any questions that you would have now? Manojji, actually, this is the end of my content. This was my last slide, and then I wanted to show this and make it more interactive from here. So in case there is something else they would like to discuss, we can.
Sure, Nimeshi.
Yes, sir.
Sure.
So probably we can take questions from the chat box, or participants can unmute and ask the questions directly.
Sure. I don't see any question here so far.
Okay. No, it was wonderful. I mean, more practical session wherein this has been integrated with actual IoT applications.
So I just wanted to give them a hands-on on, there is sometimes theory and there are practical utilities. So I wanted to show them how exactly it is used in the field today. And this is a live setup so that, it's used by the operators, the customers, and then they are benefiting by using this in their own ways to know how much a resource is being used or whether they are welding within the defined WPS or not.
Sure. Nice. So participants, you may please, if you have any specific question based on today's session or last session, you can interact with the speaker also, because Nimeshi delivered 2 sessions. Yesterday there was one session, today also another session. So if you have any specific question pertaining to both the sessions, you can ask.
So no questions gives me two
No.
reasons. One is very easy to understand. Second is probably it just didn't go well. So whichever way,
No.
the feedback is most welcome, and questions are also most welcome.
Sure.
Hello.
Yes.
Yeah,
Yes.
please.
Good evening, sir. There is one question from my side.
Please.
Sir, if the connectivity or some issues are there, like if there is a issue in, communication from receiver to transmitter, then how this system will work? Because I have observed that if there is a flood, right? So there is a connectivity issue.
Correct.
In that context,
This is a very good question. Very good question. And this is normally not only a flood, this will happen on a daily basis also. The internet is not very stable. So there will be chances where you don't have internet, your Wi-Fi is down, but your welding is on. So at those times, each one of the sensor boxes has a local memory also. It can store data up to 1 week, 10 days, 1 month. As soon as your connectivity goes live, it will do a handshaking with the server and it will dump the entire data that it has got backlog of onto the server. And from there, the server goes back live. So till that time, the server will show that this particular link break is there, but your data is not lost. Your data is stored on a local memory of the machine itself.
okay. Thank you, sir. Sir, continuation to that only.
Yes.
If something goes wrong with the system, See, in
Correct.
IoT, we are more looking for preventive, right?
Right.
So let us take this scenario only.
Yes.
There is a network issue and something goes wrong in that machine. So how
Right.
that machine will take a decision, and that machine can avoid unnecessary, unwanted happenings.
So see, there are two things. Now, in terms of welding, what can go wrong? One is you have defined that you are supposed to weld between two parameters. Okay. Now, the minute you had a handshake and you logged in first time, it will transfer that data to the machine and then the machine will operate in that range. Otherwise, it will not operate. So unless the server connectivity was there, probably your machine may not start in the IoT mode. Correct? Now, once the handshake
Yes, sir.
has done and it has got the data, then it
Mhm.
need not be connected anymore. Then it is operating only between those parameters. Now, if there is a breakdown in the machine, anyways, there are local indications and alarms which it will raise, and the maintenance team will address it. It will IoT will log and observe. So it will send the data that this was the breakdown back when the server comes online. But till then, it will not allow you to go beyond the welding parameters. However, if there is a breakdown in the machine itself, it will log it, save it with itself, and register with the server once it comes online.
Okay. Thank you, sir. Thank you.
Thank you, Prathamesh ji. A good question.
Yeah, any further question from the participants?
So I will share one more very interesting use case of this. There is each welder needs to be qualified before using the machine or working on a project, especially in oil and gas in the pipeline fields. One of our customers has projects going on in Saudi Arabia and in the Middle East. They had to validate the welders in Middle East. So there are two ways. Either they must have a third party inspector visiting the site, which is very remote, and doing the testing in front of the welder. The other option was we shipped out a couple of DMSs from India to the site. The welders had to switch on a camera and do the live welding with the DMS connected. Now, when they were doing the welding, the welding inspector sitting in India was able to see the parameters at which they were welding. And once they had finished welding, they were able to see the analysis as well of the welding result that they were got. So with visual and parameter check, they were able to qualify the welder sitting in India and not having to go all the way there. Now, welder qualification also requires you to record the data. So the data record was already done. So they could take that record and show it to the, share it with the project heads that this is what you can do. And this was what the welders were qualified at. So this is another live example of what could be done.
Nice. So I think, yeah. So I think there was a question in the chat box
Right.
regarding the use of data for the fault diagnosis.
Yes. So as I shared, depending on what we want to collect, we can collect. So use of data for fault diagnosis is used on two ways. One is the welding fault itself when they want to measure because you are having gas flow, wire speed, current, voltage. In case you see a change in gas flow, you will know exactly that this is whether it was a fault was generated because of this or not. Whether the welding parameters were beyond the WPS, you will know a fault was generated because of that or not. And if there's a fault within the machine itself, then you must capture that data as well. What are the healthy signals within the equipment? For example, every welding machine has a thermo switch, which gives you a thermal alarm, or a alarm for phase failure. That means voltage instability. If you were to carry these two data and share it back in the system, then you could analyze whether there was a phase failure, that's why your welding stopped, whether there was a change in your parameters because of which the machine stopped. So this can be also used for fault analysis. If thermal switch tripped, then it will know that the machine had overheated, therefore it stopped. So you will have that kind of a feedback.
Sure. Any further question from the participants?
There is one question by Dr. Prathamesh that can we use IoT to check welding quality? If yes, then how? So during COVID, this was really used a lot, and a couple of critical inspections that were required were carried out using not only IoT but a mix of the virtual and real work. So on-site cameras were used, IoT was used to collect data, cameras were used to see and do the NDT on site, and the data was shared back, and the inspectors or third-party people were able to validate the welding quality on that basis. And I believe so that L&D is already using this now as a standard practice. AI can be helpful for correcting faults online or prevention, but for that you need to have the prior data as to what kind of faults can occur. So AI will be only as smart as you can teach it to be. So if you were to do, because fault finding will be very specific to a process, to an equipment. If you were to feed in that data upfront, then you can probably, yes, use AI for fault finding or correcting. But the honors of feeding the data remains on us.
Okay. Fine. So, any further question? So, Nimeshri, would you like to close the session with the something on welding simulator? Few things. I mean, because that is
Sure.
something which probably many of them may not be from welding domain.
Correct. Correct.
So, if you can spare 1 or 2 minutes on welding simulator, that probably.
I'm just trying to see if I can find one which can very easily, show them the analysis. I had a lot of videos earlier
Okay.
which
Okay.
could show. So I'll just to give them an idea how this
Sure.
works.
Sure. Correct.
So that
Correct.
it will give them some. Okay. Am I still sharing my screen? Is it visible?
Yes. 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 It is visible.
Okay. So I will.
Yes, sir.
Okay, so I'm showing you two simulators. This one is a TIG welding module simulator, which will show you how you weld and what does it show. So you have to choose what kind of a person you are, left-handed welder, right-handed welder. And then when you choose it and you choose the particular welding, now this is a simulation. You can see in reality, he is moving his hand and the torch, but you can see the gap there. So he is adjusting all the gap, the gas flow, what he wants to put. He's choosing the wire diameter, electrode diameter. This is all happening in software, right? He's choosing that as a game. Now, when he starts welding, so he is supposed to weld on the white line. So without using actual metal, he is welding. Now you can see the distance he had to maintain under 5. So if he moves, you can see the distance he is showing on the screen. So he can adjust his distance accordingly. You can see the travel angle is supposed to be 115 degrees and between 91 and 115. He is at 98. So his angle of movement is correct. The orientation angle is also between 78 and 102. So that is also correct. And the filler angle, which is feeding, you can see is changing. Now, every time he is getting too close, there is an indication, please move away. He's too far. So it will tell him to go closer. If he goes too closer, there will be an alarm to show him what he is doing wrong. Can you see the red marks? Now, this is an easy way to practice welding continuously without wasting any metal or filler till you get very good at this. Once you get very good at this, you then go to the real metal plates and see it live. So we'll just see, I'll just fast forward it a bit to show you what happens at the end of it. So now he's getting scored. So his distance to torch to the job varied a bit, but not so much. So he's 71% in the correct range. His travel angle was pretty constant all across, so that is correct 100% of the times. His orientation angle was correct, so that also he gets full score. He has to work a little bit on his filler wire and he has to work a little bit on his travel. Now porosity analysis, whether the gas was there or not, all that he is able to see. Now this is what a welding simulator does. It allows you to do the welding without much difficulty. Let's see if I can show you. So this is a soldomatic welding simulator. It looks like a welding machine in itself. This is one of the plates, which is a fillet joint they have held. It's a plastic plate, as you can see. But when they will start the simulation, this will look like a real plate. Okay. And he is holding it in the actual welding position and they will start using the welding. So they need to know whether the welder is right-handed or left-handed.
So, in this welding simulators, do we have indigenous systems available in the market? I mean,
Yes, we do. There's a company called SimBot. Let me see if I can find that.
okay.
SimBot
Some,
is in Indian version. This is the one that is SimBot, and
okay.
this is very close to what Soldomatic is having, and it has multiple processes. These are the torches you can choose, and this is a mix of AR versus VR.
Mhm.
This is owned by a young kid called Varun Khatri, and they have done really a good job at learning and creating this in India. They've been, awarded some good awards and recognitions for this.
Very nice.
This is one of them, and it shows you, a cross-section view as well. As you are going through, it shows
Mhm.
you the cross-sectional view. It can do overhead. You know, it will show you when you are welding how you are doing right, wrong, whether your angle was correct or not.
Nice.
And this is the torch. He is holding the handle, the electrode, and then he will start welding as he does, and it gives you the analysis of your welding as well. So when you are welding wearing that helmet, the VR helmet, it is showing you in virtual reality what is happening. So you see the actual plate, you don't see the rough
Mm,
plates. It will show you the view now that you see that of the plate.
correct. So this was, I mean, because see, we have the participants across India, and
Correct.
probably many of them are from the diverse background. So
Yes.
this welding simulator, probably we heard the term simulators very frequently. I mean,
Right.
simulators are there for many other applications, But whether the simulators for welding applications, me and you probably we know since many years that these simulators are there in the market. But for training the welder on a simulator and then taking the welder on an actual system, that probably saves a lot of time, energy, and probably it is a more sustainable way of training the welder.
I think there are a couple of things that we must understand. We are all humans are, more prone to learn when you see it as a game. We all like to play games. It's in our nature. That's how we have been brought up. So gamification of a process is a very quick way of learning. So simulators behave like gaming. So how you play video games, you want to be very good at it. Similarly, like this, your brain starts learning very fast when you think it's a game. So one, it's a very good advantage. Second, as Vishwesh sir said, that it's a very sustainable way of doing it because you are not consuming metal. Now imagine if a new welder starts learning, he has to at least weld 20, 30, 40 coupons till he gets his practice right. 40 coupons means 40 times you have welded the plate, cut the plate, re-welded the plate, and then all that metal that you have welded not correct will go to scrap or waste. It has to be recycled. Now, this is a lot of loss. If you were to do this same thing on a welding simulator and get yourself perfected, probably then you need only 4 or 5 plates to get it right. So this is how it is a very good, sustainable way of moving forward. And of course, there are, as in anything, there are multiple versions available. Of course, Indian versions are also available. Welding simulators cost anywhere between 5 to 7 lakhs and can go upwards of up to 20, 30 lakhs as well, depending on the complexity, number of processes you choose, and things like that. But I believe for educational institutes, this is always an optimized cost. They do not charge you that what they charge corporates.
Correct. So I think this was a wonderful session, and I don't know whether participants have noticed that we go with the understanding. Although this was your second session, but Mr. Nimeshi, his background is computer science, and having a background of computer science and that too in this hardcore welding, nowadays bringing mechanical engineer into welding is a challenge. But he being a computer science background and into hardcore metal joining welding. So thank you very much, Nimeshi, on behalf of organizing committee, on behalf of AICT, on behalf of IW, PDU, and AICT, and my personal behalf. Thank you very much for sparing your valuable time and
Thank you so much.
having this knowledgeable insight for both the sessions. And I also thank all the participants for their active participations and the session chair for both the sessions. Thank you, Nimeshi.
Thank you, Vishwaji, so much for inviting me, and it's a pleasure always to be a part of it.
Thank you. Thank you very much.
Thank you, sir.
Bye.
Sir,
Bye.
if you have given such a very good knowledge, how can you forget to thank you? Thank you, Mr. Nimesh Chinoi, sir, for yet another insightful and engaging session. Your expertise and deep understanding of demystifying implementation of Industry 4.0 for welding in manufacturing setup have provided us with valuable knowledge and practical insight. We truly appreciate the time and efforts you have invested in sharing your expertise with us today. Thank you once again, Mr. Chinoi, sir. Also, I thanks to all the participants for active participant. Also, I have heartily thanks to Manoj Sahni, sir, for giving me wonderful opportunity for the today's introduction. Thank you. Thank you so much.
Yeah. Thank you. Good night, everyone.
Good night. Thank you. Thank you so much. Bye bye.